Sanbona. Here guys, we are still on the strain energy. We are given the question like this. A load of 10 kilonewton is being applied or is being lowered at a speed of 0.3 meters per second at the end of vertical length of the rope is 15 meters. The motion of the upper end is suddenly stopped. Neglect the mass rope and instantaneous elongation. Okay, here guys, we are given the information that the load it's applied, right? Kodwa it's applied kuphi to the rope. Okay, enye into engifuna ukuthi ni understand guys here is that if here we are given a length of the rope and the area of the rope, you just have to know ukuthi since I'm given the length and the area of the rope, it means the material that is going to be affected here is what is the rope is going to be affected by what, by the 10 kilonewton. So into engifuna ukuyisho ukuthi i-information ye-area and volume abazobe bakunika yona, it means ileyo material ezobe i-affecteka. You use that information, right, to calculate whatever. Okay, we are here. We are given this, the area. We are given the area and the length of the rope. So we know what it's the rope that is going to experience strain energy. It's experience ngobani na? It's experience due to 10 kilonewtons. So we'll go ahead and do. They say they want the stress inducing the rope. We know we are going straight to this equation. We know the strain energy is equals to it's stress squared over 2E times volume. This will be the volume of the rope in this case, right? But now we are given what? We are given the velocity. What we'll do by the velocity, we know what this is energy guys, and energy cannot be destroyed, but it can be transferred from one form to another form. Since we have a strain energy, right, this is our strain energy. It means this energy should be equated to some other energy, of which is what is related to the velocity. If I remember, the energy that is related to velocity, it's what? It's kinetic energy, right? Shooting knowing this, right, I can just equate knowing this and knowing what the energy cannot be destroyed by transferred to one form to another. I can equate my strain energy with my kinetic energy. How so? I can do this and say kinetic energy is equals to the strain energy, but my kinetic energy is 1/2 mv squared is equals to the strain energy is this 2E times volume of the rope. Okay, but what else do we know? The information there. We have to know our what do we want first? We want our stress, right? Okay, about the volume, this one is sorted because we have area times length. It's sorted. E is sorted, and what else? V is sorted. I'm given, but the mass I'm not given. But when you know from your high school that F is equals to mg, and I'm given what? I'm given the force. I know the gravity, meaning my mass will be just 10 times 10 to the 3 is equals to 9.81. That will be my mass, right, of the object. So it means I have every information now. I can go here and say and multiply it by 2. Then this 2 will go here and will go here again. It means I will be left with m. My m is what? It's 10 times 10 to the 3 all over 9.81. Right. Then my v is that one given 0.3 squared is equals to the stress that I want all over E I'm given as 200 times 10 to the 9 times the length. I'm given the length of the rope to be 15. It's 15 meters. Then the area of the rope is what? It's 400 millimeter squared. So I have to take it to meter squared. So I will have 400 times 10 to the power minus 6. It's already in meters now. Then I go there and punch my stress. You will get the positive and negative, but we focus on the positive. And if I punch my calculator, I get my answer to be 5.3 megaPa. This is my stress. Right. A quick review. Stentina. This is the statement, right? But I'm given a velocity, and we know that energy cannot be destroyed or created, but it can only be transferred from one form to another form. Right here we have a strain energy, and this is my equation for strain energy. But now I'm given the velocity, and if I can check from the equation of strain energy, there is no way where I can insert my velocity. But I think it's okay. No, energy cannot be created or destroyed, but can be transferred from one form to another form. If it's from strain energy, it can go to the form of kinetic energy. So then ngalokho I can equate kinetic energy with the strain energy. Equating those two, what do I get? I get this equation, right? But now I have what? I have my mass, but not in terms of mass, in terms of force. Why? Because I know the force is equals to mg, but I'm given the force, I know the gravity, I can solve for m. Already I have my m. Then the velocity right there is given as 0.3, right? Then I have my velocity right there, and it will be squared. Then I want my stress. This one is the unknown one. Then I have the E is given. Then the volume, this is the volume of the rope, but I know the volume can be written as area times length. I have the length of the rope, and I have what? The area of the rope. Let me check. It was the area. Yes, it's the area of the rope to be 400 millimeter squared. If you change this to meters, you know that you times by -6. So this is in meters now. Then I punch, I get my answer. You will get positive and negative, but you don't take negative. We focus on the positive.